Excellent. Wow, I'm loud now. This is where I work. You probably don't care. We kind of do collaboration between companies. So we're kind of SharePoint in between two businesses. The main thing is I don't work for a consultancy. I have nothing to sell you. This is an open source project I work on. How many of you are .NET devs? How many of the rest of you are Python devs? You have a Python version too, just in case. We are kind of a mix between mediator and mass transit. So we have the same kind of handler to command mapping that say you get a mediator. We can put those out over essentially a message queue to be handled out of process as well. Classic task queues. So we compete with things like Celery in the Python space or Seneca in the JavaScript space. And we have 20% time at Huddle, so that's been built and works. Huddle and the RabbitMQ implementation is very robust. What we're going to talk about. I'm going to talk a little bit about what I think are some of kind of the key myths that have been pervaded about the relationship between Agile and architecture, and name a few names of people I think who are most responsible for that problem. I'll then talk about what is software architecture. I don't know how, because most of you guys raise your hand saying you're architects, and we'll see whether we all agree. And I'll talk a little bit about what is Agile. That's quite short. I'm not going to talk about tons of Agile methodologies. I want to get to what I think is the crux of what makes something Agile. And then relates to then how should we practice architecture in an Agile environment? Because some of your architects, we may give them time. I don't know how much time I spent in the last section. It's kind of like useful in some contexts, which is distinction between a role and a job, and whether it's a job or a role and how you assign it. But we'll see what happens. Okay. The myths. So who knows who Martin Fowler is? Presumably a lot of you, yeah. Okay, so most famous for writing a refactoring book, writing Patterns of Enterprise, Application Architecture, and despite writing a book called Patterns of Application Architecture, Martin doesn't really like architects, and he famously once said, "We should never hire anybody at ThoughtWorks who has the architect in their job title at any point on their CV." And he said, well, if you want to define architecture, it's really just a way that we essentially give people an inflated title. For doing design, and quite often, they're more senior. You want to keep them in the company, so we try to pay them more money. So we give them the title architect to justify paying them more money. That was Martin's kind of opinion on what architects were. Not particularly high. He also said once that architects, they always remind me of the guy in the Matrix, right? So, and Martin's actually, I think, as a result, that's responsible for a lot of the feeling on Agile teams that we're self-organizing teams. We don't need no architects. And he does a quote from Ralph Johnson at one point, though, saying it's decisions you could get right early in a project. So you might need architects, the things that basically are hard to change. And this is quite a pervasive idea in the idea of Agile architecture, that it's focused on things that are hard to change. But the problem a little bit is I think what's happened is it's now perceived that architecture is about things that are hard to change. And indeed, Martin even reaches the point where he says, really the job of the architect is just to make themselves redundant by helping software development get to the point where there are no hard to change things anymore, so we won't need you. And he gives the example of DB migration. He says, once upon a time, the wisdom was that the DB schema was very hard to change. And so we needed to sit down up front and map out our DB schema and figure out our data dictionary and have all these vast spreadsheets telling us what the data structures look like, because schemas were hard to change. And somebody who was working with at ThoughtWorks said, well, if I take the old schema and the new schema and I diff them, I can create a migration script that automatically essentially allows me to move between versions. And the whole process of migrating, as evidenced by things like Rails that came later as a result of that research, becomes very easy. And now I've taken this thing that was a hard decision we made up front, and I've actually made it a very easy transition during the project. And one of the roles that architects need to fulfill has been removed. And eventually, through a process of Agile improvement, eventually we won't need anybody to do architecture roles. And we'll all be wonderful, self-organizing teams. Right? And he even objects to the whole use of the term architect. He says, actually, if you think about what architects do, they do nothing like what we define as an architect. Because architects are focused on the usability of the building, not in any of its engineering. And they're much closer in construction architects to being UX guys. The term's even bad. He even hates the word architect, right? If you're an architect, Martin Fowler hates you. And Grady Booch even kind of really picked up on this meme that was doing around. And Grady Booch says, that it's basically the significant design decisions where architecture, the significant design decisions where significance is measured by cost to change. And I have a bit of a problem with here because so what happened a little bit was when you took traditional waterfall methods, those methods had a distinct phrase up front, which was basically architecture, requirements gathering, design and architecture, coding implementation, and QA. And when people began to move towards agile approaches, they said, well, now we're iterative and incremental in these small loops where we're doing coding and getting QA and getting requirements from the user. So this architecture, which is this kind of the big set of ideas we have about how we're going to build the system, that's no longer appropriate because what we're doing is building in tiny little steps. There's never any point to do architecture anymore. There's never any point where that will occur. So we don't want to do architecture. We just want to basically code and we'll use TDD and some kind of refactoring process to produce our incremental architecture. And the only objection they could see to that was that some of those things are not easy to change, right, by just doing a bit of refactoring. And you need to, rather than refactor, put your tools down, have a bit of restructuring. So maybe they would allow for this idea that there was some architecture requirement where there were things that you were going to do in the project that were a bit too hard to change as you went along. And those were the things that essentially you would then choose to call architecture. The things that you just couldn't do with a kind of a TDD refactoring incremental approach. And that was architecture for them. And it's kind of a weird definition, if you think about it. Because it's saying that architecture is a kind of temporal property of the system. It's a time-based definition. It's saying it's the stuff you're forced to do because you can't change it later. And that's very interesting because since the 1990s, software architecture has been a field where quite well-respected individuals at universities have been studying, writing papers about it, books about it, and none of them define architecture that way. And it also kind of implies that architecture stops at the point when people begin building a system. The architect's no longer interested. He can just wander off somewhere else because he's made the hard decisions up front, and now there's no need for architects anymore. Any decision we make now is just design. There's no architectural element to that design. And I think that's very counterintuitive when you begin to think about it. Okay. So what I want to talk about first really is what is software architecture. I think I need to define what I think the software architecture is in order for us to get to understanding of how we use it in an agile context. So the first thing I wanted just to take on is this challenge of the use of the word architect. Okay. So the first book we ever had on any kind of architecture, it's called De Architecture. It's by a guy called, I have to read it unfortunately, Marcus Vitruvius Pullo. And he was a Roman engineer in the army who worked for Julius Caesar. He actually, although he wrote the book on architecture, spent most of his life in command of a trebuchet unit, flinging large rocks at pieces of architecture to knock them down, somewhat ironically. But he wrote this seminal book on architecture. And at his era, architect was basically an engineer, okay, someone who essentially built things. And he defined this idea of what we see as the three key principles of architecture. That's in Latin, so we'll do it in English. Durability, something needs to be robust, it needs to basically stand up, it needs to remain in good condition over its lifetime. Utility, fit for purpose, and beauty, should be aesthetically pleasing. And that's actually not a bad definition of what we tend to try and do in terms of good architectural design as goals in software. So I think it's reasonable to use the phrase architect. What actually happened was it's not until about the 19th century that architecture loses responsibility for engineering, when engineering becomes a separate discipline due to basically the growth of new materials being used. But up until that point, the architect is really somebody who is also effectively an engineer. So if you join a team and ask them to walk you through the architecture, what would you expect? What kind of thing, what would you expect them to do for you? Anyone? Second? Show the source code? That could be one way of doing it. That's quite hard work. It's a lot of stuff to do. What else might they do to show the architecture? Sorry? Diagrams, right. So generally speaking, my expectation would be someone would basically go to a whiteboard and draw a diagram. And I'd also expect probably that it would be a kind of boxes and lines diagram, right? I wouldn't really probably expect much UML. I'd just expect some boxes with some lines between them, where the boxes were something important the system did, and the line said, and this thing talks this other thing. And there'd be a narrative discussion then essentially saying, why do all these things talk to each other? And there might be a discussion of saying, well, why? Okay, why do we do it this way? And why does this bit talk to this bit? Why does this bit talk to this bit via message queue and not HTTP? Why do we use gRPC here when we've used message queuing everywhere else, right? There might be some discussion of why decisions have been made as a result of the process. What I wouldn't expect is someone to say to me, oh, well, I've got a list of the decisions that were too hard to change. That's our architecture, right? That's just weird. And actually, Martin refers to Ralph Johnson, and he refers to Ralph Johnson in that paper, and some of the things that Ralph Johnson says work against Martin's own definition. Right? He says essentially that nearly all competent teams have an idea of what the architecture is. It's a kind of shared understanding of how all the moving parts of their system fit together. And it's how we divide it into components and the interfaces between those components. And this is quite a key idea in understanding what software architecture is. It's components and the interfaces between those components. And it also says, and this is another quite important point, any one of these components is probably a thing that could be subdivided, right? So I talk about my, picking an example from Huddle, talk about my files service, right? One of our microservices. Within that, of course, there are classes, and those classes essentially effectively have interfaces that talk to each other. But going to that level of detail when we talk about the source code may be counterproductive. What we care about from the architecture is a level where effectively we can reason about the properties of the system to understand things that are significant about the system. Where significance is kind of like to be decided. Okay. So in the 90s, Mary Shaw and David Garland wrote a book called Software Architecture at Carnegie Mellon University. And that's quite a kind of seminal work on defining how this thing called architectural styles came into being. And they say the designer specification of the overall system structure is the key to understanding this idea of architecture. And they say once you get more complex software systems, this is what's happening in the 90s, this notion of needing architecture begins to grow. And it's a description of the elements systems built and interactions amongst those elements. In particular, the methodology they use has components, which are boxes, which are the locus of state and computation, and connectors, which are lines between those boxes. And they just draw all those diagrams with boxes and lines. So if you look at boxes and lines diagrams, that's actually how the academics say, go away and draw up your architectures. Okay? And then they use this notation to define a whole range of common architecture styles, pipes and filters, layers. There's a whole range of them. And then one of the things they went and did with that was use that process to compare architectures, to say, this architecture is good for this context, and this is good for this context. And there's something called the candidate problems list, where essentially there's a set of about 13 varied problems, everything from essentially a website, but the equivalent in the 90s, to a automated do you say buoy or buoy over here? I can't remember, but thing that floats in the water and warns shipping off crashing. So there are obviously quite a range of problems, and saying different architectures that are suitable in some of these circumstances, and others are not. Anyone know what one of the most famous architectural styles that basically emerges out of this work is? One of the most famous papers? I've looked up the name. It's called The Architectural Styles and Design of Network-Based Software. Anyone know why that's important? That's the white paper that defines a REST. This is where it comes from. There's a collection of components, interaction amongst those components. So a component, we mentioned that, is a locus of state. Connector is how they talk to each other. And architectural styles are vocabulary. Okay. So anyone ever read Software and Architecture in Practice? Okay, you should really go and run and buy that book if you have software architect anywhere near your job title or responsibility. It's a pretty big textbook. Includes things like ATAM, which is the Architecture Technology and Assessment Method. We'll talk about that in a second. But some terms you may have heard of come from there. And it's at a Carnegie Mellon University again. And those guys say it's a set of structures that needs to reason about the system. And that's the important phrase, I think, reason. Okay? We want to be able to talk about the system, what we expect, how we expect it to behave in a production environment. And so to reason about the system, we need to understand what the bits are and how they work individually and how they communicate with each other. So structured architecture supports reasoning about the properties. There's a notion that essentially we can't know everything, right? We're going to have to drop some elements out as too much detail. We're going to have to focus on the key elements of our structure that will help us understand how this is going to work. So 3 examples these guys give: model structures, right? What does a module look like? Component collector structures, again, the same topic that's come from Mary Shaw and David Garland, this idea of things that compute and how they talk to each other. And allocation structures, how do we allocate those out to hardware? So I like to think of this really as what is software architecture? I would say software architecture is certainly not this idea of the significant decisions, because that's a story of how we came to live here, but it doesn't tell me where the grocery store is and where to buy. I would say petrol. You would say gas. Did you know that the most contested article in Wikipedia's history is not things like the Israel-Palestine border? It's petrol and gas, and it consists of Americans going in and renaming the article gas, and Brits going in and renaming the article petrol, and it became so divisive it almost finished Wikipedia. There we go. But I think the architecture is a map of the system. Okay, and it's how we essentially figure out our way around all the code that we're writing and implementing, how it all fits together. And like any map, it's an abstraction. Okay, so I can have a road map, I can have a topographical map. I can't say that word. If I want to go, hiking in the hills, I have different types of map. So I may have different representations of architecture. But the map is essentially, as Sun Tzu used to say, right? If you don't understand the terrain, you're going to lose the war. The map is how we figure out how we're going to win the battle of implementing the software system. And that's what architecture gives us. It gives us the map so we can start reasoning about our approach. Typical maps that people talk about. 4+1 view, anyone seen this before? So 4+1 is the traditional way that you do architecture in diagrams in construction industry. And Philip went away and essentially said, here's a software version of this. So the logical view, this is where essentially you put your things like your domain model, right? Put your UML with your class diagrams. That's where the output of your CRC card sessions go. The development view is more about modules, packages. It talks about how we essentially cluster those into deployable units. The physical view is literally around what is the hardware I'm deploying this to. And the process view is things like sequence or activity diagrams where we have a temporal element to that. And so it's a set of maps that you can use to define architecture. And you will find, if you read through architectural literature, that visual diagrams of architecture are seen as a key way of documenting and expressing architectures, maps of the system. Don't worry about reading the detail. This is Simon Brown. Most of them have, by the way, a little note with the person and the book it comes from on the side. So if you want to go and actually dig more into these, go and note that. The slides will go up at some point. You can reference it. So Simon's got a white paper called Visualizing Software. Here's something called the C4 series. Anyone heard of C4 diagrams? So C4 diagrams, that's basically context, containers, components, and one down, which is classes. It's a way of doing a stepwise refinement of viewing into the system. So the context, essentially, the black bit in the center is essentially your system, and that's everything it's talking to on the outside world. Then you get a container, which is something like your web app or your database, what's running inside it. So IaaS hosting your software, for example. And the components are inside that, what are the modules that make up my particular piece of code. This is a components and connectors diagram from mid-90s architectural styles. Component, which is basically state, connect to the line in between it, which says, I'm going to talk via a socket, or I'm going to talk by basically MQP across the message queue. And at the end, basically, of the component, generally you're a role. So client server, producer consumer. And you have an interface or port which effectively allows you access to that particular container. And the simple heterogeneous note is just that it's components all the way down. So any component can be redefined as probably a set of component connected diagrams. So you have to decide what level to map to, right? And that's the level which is essentially going to give you enough significance to understand the properties of your system. When you join a new team, how would you assess, do you think, whether the architecture was good or bad? What kind of criteria might? And obviously, we can probably exclude. I just thought if I look and see whether it's like already a big ball of mud, and then I'd eventually walk away in horror. Anyone got any ideas? Any thoughts? Could be. Yeah. I mean, I tend to look for suitability for purpose. Okay. So it has only essential and not accidental complexity. Do you understand this distinction between essential and accidental complexity? Essential complexity is just the stuff I need to solve the problem. Accidental complexity is things that unfortunately get brought along with whatever my solution is that I didn't really need in the first place, but are now adding additional complexity to my problem. Okay, and so quite often we define languages as having essential and accidental complexity for solving a given problem. Is my type system actually helping me here, or is it accidental complexity that becomes a burden for me? Right. So you can have essential and accidental complexity in a software system. Ease of modification to changing requirements, right? I've hit this one a few times. When I used to work for a UK insurer that was building platforms actually for the US, and a team went away and built this system that was built in reasonably good time. It was done in very close cooperation with the actual end user who loved the system. It meets our needs spectacularly. And everything was going swimmingly. Most of that team were contractors. They left. And people who were asked in the old days were handed over the software and asked to look after it. The customer came back and said, I'd like to make some changes. And the team went and looked at it, and it was a disaster. Because they'd done this whole process where every single page in the web page had a kind of unique store procedure which essentially pulled all the data for that page, and a unique store procedure that wrote all the data from that page to the database. And any modification was complicated. It involved altering the front end, it involved rewriting the store procedures, and it was very expensive to own. And so while it had been seen as a success because it was easy to deliver, it was very expensive to own as a piece of software. So one of the ways this tends to be expressed is this idea of a quality attributes. Anyone heard of quality attributes? This is referred to as the ilities. Okay, so quality attributes basically the real place to go and look for that, as I mentioned earlier, software architecture by Clement Spass, etc. That's the place to really go and delve into that. And quality attributes tend to be how we assess architectures. So the first thing you're going to have for any system is just set of functional requirements, right? The software must be able to, I don't know, track jet aircraft coming and going from my airport. But the next thing I have is the quality attribute requirements. And as architects, this is essentially what we care about most. Some people call these non-functional requirements. We tend to move a little bit away from non-functional requirements now because quality attributes could actually be functional. But they refer to all the things that probably aren't explicitly covered in the functional requirements. So the classic list of the basic ilities you should care about: modifiability. That's how difficult the software is to change. It's also how expensive it is to own operationally. Okay, how easy is it to deploy? How easy is it to basically integrate together? At runtime, how easy is it to spin up a new instance of the process in response to basically scaling demands? How easy is it for a developer who's tasked with, say, writing a new API to add one? How fast can they do it? Quite often we measure things like, how long it would take less than 2 days to implement a new API in the system. Usability, that is both the usability of the UX, but also the usability of things like your API. And in a world where we tend to now be more API first because we have web clients and mobile clients, and we need to care about the usability of the system. Security, obviously, we care about whether it's secure. Testability, right? How easy is it for us to prove that the system is correct? Performance, how fast does it go? Quite often you'll see requirements like The web, a GET must respond in less than 300 milliseconds. In order to scale, typically web servers need to respond between about 200 to 300 milliseconds at an upper point. Otherwise, they won't scale very well. And availability. By availability, we don't just mean is it up. We also include things like transactionally. If I give you some data, will you guarantee effectively that you will then store that safely for me? And that list is a typical set of concerns that you as the architect have in order to prove the system has a high quality. Now, we'll get into later about how you figure out how much effort you should spend figuring those out. But generally, the thing to understand is there are classical trade-offs between them. So modifiability and performance are a classic one most of us understand. Okay, I can write this code to be very fast, but now it's very hard to maintain because I've gone and done some interesting things with the threading library that mean that half the developers on the team will probably break it if they touch it. Okay, and that may be necessary to achieve those performance requirements, but it may not be. We have to understand what are those two trade-offs between the modifiability and performance. Which side do we need to flow? And generally, what you have to do is look at the business requirements, right? And go. You have to ask difficult questions of the business. You have to go back to them and say, how fast does it need to be? Do you care more about how quickly you can turn around new features, or do you care how secure it is? And those things become trade-offs you have to discuss with the business. And constraints. Every system has constraints, so things you can't change, right? And you as the architect has landed with those. Typical constraint would be you have to build it in Java, right? Because we know we're a Java shop. Everyone's doing Java here. It's going to have to be Java. Even if you think Go is a better choice, we're doing Java. That's a constraint. Live with them. So as useful book, design it. I'm mentioning Jess a couple of times in the front row. So design it's a really. If you ever read Release It in the Pragmatic Programmer series. Okay, there are two books, if you're an architect, you should really read in the Pragmatic Programmer series, Design It and Release It. Release It is one of the worst named books ever because it's nothing to do really with releasing software. It's all to do with basically system reliability engineering. It's a fantastic book and you should probably put it on the list. It's where people came to understanding like circuit breakers, retry models. That's basically comes from there. And it's all about what we would now call a system reliability engineering function or an SRE function. Design It is really about the process of doing architecture. It doesn't detail how to use all the techniques that you might want to use, but it's very good at showing you how to apply the process of being an architect using those toolkits. So here's what one called a quality attribute web. It's a kind of workshop activity you can do as an architect where you put together a kind of web file diagram with the key quality attributes on the side, and those yellow post-it notes represent scenarios you've been given by the business, and that you prioritize them by putting them closer to the circle. So you can begin to see what are your trade-offs, right? I need to be really fast. That modifiability requirement, that may be one I have to sacrifice. Partitioning. So one of the other things that architects tend to do in order to produce quality systems, as well as focusing on attributes, one of the key roles of an architect is to partition the system. And that helps you meet quality attributes. If the system has a number of pieces, it may be easier for me to assign relevant quality attributes. This part needs to be fast, right? I can partition it away because then I can meet modifiability requirements elsewhere. Smaller things are generally easier to reason about design and testing. So this is a typical way we do partitioning. Anyone know what this is? Anyone recognize it? Okay. These are bounded contexts from domain-driven design. So these have become, quite famous recently because people talk about partitioning microservices along the lines of bounded contexts. And it's a way of splitting up your domain model such that essentially you say within a given context, a term has the same meaning, but may have slightly varied meanings outside. So the typical example I use is insurance. Insurance has a notion of a policy, an insurance policy. But the data you record about the policy and the behaviors of it are quite different for an underwriter who really cares about saying, how much money am I going to charge you? To the claims guy who's saying, wow, your roof basically had a huge leak, and now I have to assess how much we have to pay you. Both of them use the word policy. What we've learned over time is simply adding into the attributes of policy the ability to do all of those things is very hard work. So putting them in two contexts, an underwriting context and a claims context, I'm able to simplify how I reason about policy. Because in the underwriting context, I only care about things that affect underwriting. I don't care about things that affect claims. Years ago, I used to work in insurance. Some guys came to us and they said, we have this insurance model that's off the shelf. My CTO said, Ian, you've got to go and talk to these guys. They're saying that for $40,000, they can give us a model of all insurance. It will save us so much time. And I went and talked to them, and it was crazy. They had a model which essentially had a notion of a policy that covered all possible policies, from life insurance to car insurance to commercial business insurance. They said it had about 2,000 properties on it, right? Completely unusable, really. But the problem that they had was that essentially they had no bounded context, right? They'd simply lumped all of insurance as a domain model into one place. There's no partitioning taken place. So partitioning is how we break a system up to reason about it more effectively, right? There are other partitioning strategies, but I mentioned basically this one because it's a very popular one right now. Coupling. Coupling, essentially, this is a famous essay by on the criteria between decomposing systems and modules by David Parnas. And this is really kind of one of the early places where information hiding appears. This idea that I don't want to depend on details that might change. I'd rather depend on stable abstractions. So we create an idea of a module. There's some kind of stable interface. That thing's going to, it's going to tell us how to basically make, I don't know what's a good example, to price basically your policy that you applied for in terms of insurance, right? I'm going to call that, it'll give me a price back. What I'm actually asking it for tends to remain stable over time to give me a price. How you implement it might change. You make up better algorithms all the time. So I don't want to understand those details of how you do that. I want to depend on the abstraction, and underneath, you keep changing stuff. So we reduce coupling, so we only couple to stable abstraction. We don't couple to unstable implementation details. Okay. So that's a kind of whirlwind to a what is architecture. There's a lot of references there, a lot of things we want to dig into. But at the book Designer, I'd recommend if you're looking at that going, wow, that's loads of information, Ian, and loads of people are supposed to be going and reading, Designer is a really good book for giving you that kind of landscape. Okay. What's Agile? So I'm quite short on this. So this is how people before, anyone actually remember the days before Agile like me? Anyone old enough to have worked in a pre-Agile environment? And my commiserations, guys. So this is kind of like how we used to do it, right? We had distinct phases. So you start with the requirements gathering phase. People go away and talk to the customer, they get some requirements. Then you have a kind of a design phase, and you go away and figure out how you're going to build the system. Then you write code, you write all the code, and at the end you test it. Obviously, the problems was, you just got a problem right in QA. It could have been a design issue, a year ago that caused that. And I had the great fortune to work at a time when I was in an Agile team. Nexus was basically a phase development team. And the phase development team shipped a system. And the customer said, this is useless. And they said, but it's exactly the specification you gave us. And the customer said, well, who gave you the specification? They said, well, Dave gave it to us. They went, oh, Dave's an idiot. He doesn't know anything. Right? And there's no validation in the process. The feedback loop's too long, and therefore you can make multi-million-dollar mistakes. And it costs about 14 million, that mistake. Right? So Alistair Cockburn basically does a talk called What Makes Agile Work, and it's one of his diagrams I've stolen. And it says the problem effectively with these structured methodologies was that effectively, if you compare knowledge gained on the vertical axis to time, you gain knowledge at the point where you're doing the QA and the system, putting it in front of the users right at the end, and it's far too late. Okay. So you want to have a strategy of risk reduction where effectively you are gaining knowledge much earlier. So rapid application development was kind of how this emerged. Application development work with Steve McConnell kind of was the Kickstarter to the Agile movement. And it said, well, let's just have these short incremental iterations. Incremental in the sense that I build a small bit of functionality and then validate it, and iterative, and I keep doing that process again and again and again and again and again. That's basically the kernel that becomes Agile. Note, though, that there is a phase at the beginning before we begin the iteration, the incremental and iterative process, where we do a little bit of requirements analysis, a little bit of design and architecture. Think about how we work today. Usually the product team or your BA, whatever you call it, is going to come to you usually with an idea of what he wants you to build. Something has happened before that process kicks off, and that's quite often that. Okay, I'll come back to why that's important in a second. Okay, this gives us a model that looks a little more like this. Early on, we begin to actually validate our approach, both in terms of the functionality and the way we're building it, and we're getting feedback very early. So we have an early learning strategy. We reduce the risk of our overall system by making sure we learn early. So unfortunately, this is the Agile Manifesto. Right? Here's the thing about the Agile Manifesto. Lots of people quote it as being what Agile is. It's basically nonsense. So what happened was a whole lot of guys who were working on these RAD methodologies, etc., got together and held a meeting, and they couldn't agree on anything. You know how occasionally we have a kind of like a peace meeting, and the UN organize it, and the world leaders get round, and at the end of it, make some bland statement where we'll continue to work together, mutual respect. Nothing got solved, right? Agile Manifesto is the same. Nothing got solved. And that was the blandest statement they could come up with that they could all agree with. So please don't use that as a yardstick for what is Agile. Because it's essentially like saying, peace in our time, right? It's rubbish. So this is mine, but I think this is a better definition of Agile. It's a risk reduction strategy that focuses on shortening the feedback loop. In other words, the time between I make a decision and I validate that decision. To get validated learnings on requirements and design. In other words, to say essentially, if I say this is a requirement the customer has, I can validate that with the customer in the shortest time possible. And make a design decision, I can validate that it works as quickly as possible. But the key thing to understand is it's a risk reduction strategy, right? That's going to be important to us. Incremental and iterative. Your goal in any iteration is not just to burn the house down to deliver this iteration, by the way. You also have to make sure the next iteration will also work. And because it's incremental and iterative and has a short feedback loop, we can say we are responsive to change. Make sense? It may not be lightweight or low ceremony. There is this myth that Agile processes are lightweight. Lightweight does not enter the definition, right? It's all about feedback loops and risk reduction. If we need a heavyweight process to do that, that is fine. Okay. So how should we practice architecture and Agile? Well, let's talk a little bit about what some people have tended to say in the past, right? And this key idea emerged from some people looking at things like XP, who said, well, what you have to do is deliver value to the customer. If I'm delivering value to the customer in something like XP, then surely I can't work on an architecture. I have to work in the first iteration on stories that basically benefit the customer, right? So the only way I'm going to really do any architecture is I will implement that with TDD, and then I can have a refactoring step. And as each time I go through a given increment and I learn more, then what I'll do is essentially refactor my way to a better architecture. And the idea is that I'm never going to add any code unnecessary. So the danger with my upfront architecture would be I'm building lots of structures I don't really need, right? So I'm going to do this incremental approach to adding value and then just go through. But even people like James Shaw admit, and by the way, his book's a great book. If you want to understand XP, it's a great book. But even he admits that occasionally what happens is we kind of down tools for a bit of a restructure. So in other words, rework, right? And the danger here is this. If we say that the architecture of a system is its structure, its components and its connectors, right? Then every system must have an architecture. If we didn't choose it, we now have an accidental architecture. If we get lucky, it could be fit for purpose. Otherwise, maybe not. And Alistair Coburn wrote a very good book, Agile Software Engineering. If you really want to understand a lot of these topics better, that's a key book to read. Says that's really great for people like the original Chrysler team who basically practiced XP. We're all experienced developers. And intuitively, they understood as they went through all these phases of doing TDD, of doing red, green, and refactor, what they were working towards. They understood how you would be structuring systems correctly to behave. And so effectively, they were practicing good architecture because they had a mental model that was unspoken almost of what they were actually working towards. When you have less experienced teams, that may not be true. You need to basically give them the opportunity to explicitly consider what they need to do to have a successful architecture. So what are they going to do to think about all those quality attributes? What are they going to do to consider all those constraints? There needs to be some explicit point where they can say, we should think about this, and particularly if you're an architect with a less experienced team, how you can guide them. Let's return to what Grady Boots said. He said, is the measure significant by cost of change and impact upon use? And so it's at this point, I think, when we begin to think about, actually, hey, if we're going to have walk this team through some kind of notion of us supporting them to do just enough architecture to get started, maybe then this phrase becomes useful because it says the just enough architecture is looking at the significant design decisions, right? So that it isn't a definition of architecture, but it's a definition of what architecture might want to do on an agile project. And so the crystal methods that basically Alistair Coburn defines in agile software architecture have a phrase called exploratory 360, when essentially you ask the question, could we, should we, how would we? And you spend up to a couple of weeks together having some conversations, whiteboarding diagrams out, trying to figure out how you're going to build the system. And it even has an idea like spikes from XP, where you say, I don't understand how this works. I don't feel comfortable about it. I'll tell you what I'll go and do. I'll go and basically try out this technology so I feel more comfortable about it. And XP has this kind of model with spikes that says, you're trying to get enough knowledge to create an estimate, right? And the reason that yardstick is used is if I can estimate something, probably I know enough to feel comfortable it will work, and any further implementation should be done in iteration, right? Just getting a feel for how much work to do. Strangely enough, XP also has architecture. It has a distinct exploratory phase. In the exploratory phase, you do architecture. And it says, up front, you do a number of little experiments to prove that the architecture is actually going to work. So none of the Agile methodologies, if you go and read them, actually say don't do architecture up front. What they say is just do just enough architecture up front in order to feel comfortable about the next step. And then after you've done your initial architecture, your target is something called walking skeleton and incremental rearchitecture. So your walking skeleton, and it's something that the pragmatic programmers call something like a tracer bullet, which is very similar, is just enough of the system to span your architectural risks. So you say, well, here's roughly what I think might go wrong. So the first thing I'm going to prioritize is building enough of the system in the first iteration that I can essentially disprove those risks or prove them. That's a fail fast strategy. If the decisions I've made architecturally are wrong, I want to fail rapidly, not in 6 months' time when I have a sense of rework to do. And I can rethink. And I may have to rethink with the project viability at that point. It's a fail fast approach, and you say, I build just enough of the architecture. The other skeleton is it hasn't much functionality, much flesh on the bones, right? But just enough of the functionality, prove the architecture. And then you enter your incremental re-architecture phase, right? Having limited the key risks, I can now do my normal per iteration, incrementally re-architect the top of the system. Excuse me. I'll let you read that. Anyone familiar with the walking skeleton? This is the first time for you to kind of come across that. So what we tend to do, where I work, is say that the goal of an architect is really to define what is the walking skeleton and what will it address. And that's what we do in the initial kind of exploratory period. We say, what risks should I address? What is a walking skeleton that addresses those risks? That will be our first milestone on the project. After that, we will deliver business functionality. So this is a knowledge reduction strategy, a knowledge growing strategy, risk reduction. Early on, we are saying we want to reduce the risk of this project. We want to acquire knowledge, and we're going to do that by fleshing out the problems with our engineering and design. Remember we said this beforehand? How to have a risk reduction strategy. So if you are an architect, you may have an extensive toolbox. I don't know. These are the kind of typical things that we may know about. CRC cards, people familiar with those? Getting 3x5 index cards and writing classes on them and playing games where effectively you move things to the system. Okay, read object-oriented design by Rebecca Worsbrock. I can't remember the name of the book. Let's look for Rebecca Worsbrock. Her book is kind of the key book on something called RDD, or responsibility-driven design. And there's a precursor really to DDD. Eric Evans actually assumed he read Rebecca's work, right? So go read Rebecca Worth's blog. ATAM and quality attributes, that's software architecture and practice you need to read to understand that. ATAM is a method for assessing architectures through quality attributes. RDD, which you mentioned, architectural styles, Mary Shaw and David Garland, cataloging the properties of things like pipes and filters, layered systems, REST is an architectural style, CQRS is an architectural style, event sourcing is an architectural style. Patterns of software architecture, so the POSER series, take the Gang of Four idea of design patterns, but elevated to architectural patterns. So you can see what your context is. Has someone solved this problem already, right? Frameworks, architectural hoisting, which says essentially the idea that I'm going to give you a framework, and that is going to, if you follow the patterns and implementation choices of that framework, many common design issues will basically be solved for you by using that in the first place, right? So something like Angular is essentially a way of packaging up, understanding how to build SPA apps and giving it to developers to reduce risk so you can get less experienced developers working on them. Presumptive architecture, that's what your standard is inside a company for doing something. If that just works, someone can use the templates and the cookie cutter approach and build another one, right? Sequence diagrams, event storming, a whole lot of these things, right? But you don't want to use them all. That'd be really expensive. So what you want to do is just figure out what are the project risks, which of the tools in my toolbox help me resolve them, right? So the other day we were talking about Huddle, changing the way we implement our antivirus so that essentially we do it immediately on upload in a buffer. And when we talk about the key architectural risk of that project, it's really about scaling that in a performant way. We have to have basically a buffer area somewhere in an EBS volume where effectively we can put the files. We have to be performant enough that those buffer doesn't become overwhelmed and queue too much. We have to have enough AV processes running essentially at once in order to basically meet the demand. We have to think about scaling up. That's our key risk, right? Some stuff like the HTTP endpoint, which you already have, is not a key risk. Don't worry about that. So you address the key risks in your architecture. You say, what could go wrong? What's difficult? What don't we really understand? That's where you focus your architectural effort. There are obviously lots of different ways you may think about that. So this is a model. It's called How Much, in a paper called How Much Upfront by Waterman, Noble, and Allen, which talks about, sorry, I'm just laughing because he was holding up my time check and the piece of paper folded down, so I couldn't see how much time I had left. Okay, so the boxes represent forces and the rounded edges boxes represent strategies. So the forces are things which essentially are often in opposition to each other. So you can see we've got things like team culture, customer agility, and experience. The ability to do Agile depends on those. A highly experienced team, both in software development and in terms of agility, may need far less help, maybe able to go straight into incremental architecture. Whereas a team with no experience of Agile, lots of junior developers, you may end up actually being better off with more a planned development style and doing more development up front. Okay. So those forces affect what you do. But the key ones to understand up here is that there's technical risk and you have to address risk. In order to address that risk, you have to look at a number of options, frameworks and templates, or your mapping to emergent architecture. How much are you going to rely on emergent architecture? How much are you going to design up front? There's always a trade-off. And there's generally, there are several models on numbers, or I wouldn't worry about that too much. What I'd worry about is saying, what I need to understand for any given project are my key risks. There's an exercise called risk storming, where effectively you get everyone in a room and you say, what do we think the key risks in the project are on the team? What are you worried about? Right? And some of that you have to understand things like the quality attributes, because you can't understand a risk without them. How fast does it have to be? Well, we're worried about the performance numbers that we've agreed will hit, for example. What's the availability? We're worried about hitting 4.9, right? So those things give you the key risks, and that's where you focus your architectural effort. There's a map, right? Architecture, an abstraction, and it admits some details. You're focusing on the key ideas for your particular project, the key risks that you need to track down. And that's where you focus your architectural effort. And that stops architecture being this massive upfront activity, which creates lots of cost and annoys the developers because they're like, you're micromanaging me, and actually works with them to help define stuff. So who is a software architect? Simon Brown's got a really good book, Software Architecture for Developers. If people are in a kind of more development role and got promoted to an architecture kind of hat and are saying, what do I do as an architect? That is an awesome book. Going to help you through that process of understanding that architecture doesn't mean I'm the most senior developer on the team. It actually means I have a range of responsibilities. And he defines that as being what you should do. Note that coding is in there, right? Nowadays, if you are a solution architect, we tend to expect you to code, right? Get your hands dirty. Don't be a general sitting behind comfortably, in your tent drinking your brandy while the troops are off fighting. Get down there and get dirty with them. If you're an enterprise architect, it's a slightly different role. So we're not going to talk about that today. But you have to be involved in all these things. What is the vision of the architecture, right? How are you going to evolve it? What are the risks that you care about? What's the quality assurance? And those are the kind of things you need to get involved in. Okay. I tell my team a simple version. If you're an architect, you have 3 key things you need to do. Help the team build, mentor the team, because you probably have a lot of experience that you need to pass on to them, and mentor them in software architecture as well as just simply writing code. And stakeholder management, because you have an outward-facing role towards all the people who are non-technical, because you have to gather data from them. In other words, what are the quality attributes for this system? And you have to explain stuff to them. For example, no, you can't do that. It's never going to basically meet the quality attributes you've already set for it, right? So we had a discussion the other day with one of the product guys who said, I want all this done and the performance shouldn't change. We said, can't be done. Not that a lot of money, more than you're prepared to pay. Here's why. At the end of that, he said, okay, you've given me a new view of what my priorities are, and I'm okay with this much slippage on performance. Okay, so that's stakeholder management. It will involve you in organizational politics. If you don't like politics, it's a tough role, right? This is from Discipline Agile Delivery by Scott Ambler. So I'm only using it because it's got some nice diagrams that are really helpful. If you do work in a highly regulated environment and are wondering how you can do Agile, it is really helpful. It's designed for people working in regulated environments like government or healthcare, et cetera, to help them understand what Agile is. And one of the things there, they talk about what are roles, right? So architecture owner is a role. And the suggestion is if you have a small team, and that team, by team, what Scott's really referring to here is number of people involved in the software project. And if they're small enough, you can organize them into one team, you might find that the team lead is also the architecture owner, right? The 2 roles can be combined. Can be too much. Depends on the experience of the team lead. What's their experience like? Is it too much work? The team gets big, both to be the team lead and to actually do the architect at the same time. You can split the role out, but at that level, you don't have to have a separate role. When you get to about 10 to 40 people and you have sub teams, generally you're going to need some kind of architect, because you have to have somebody to oversee what all these teams are doing, making sure that they're adhering to the plan, and you need to kind of sit outside the individual team structure. When you get up to about 30 or more people, you tend to embed an architect in each team, and they act as a horizontal team. So they essentially bring the architecture concerns into the team from across the group. So people talk all the time about self-organizing teams, and they say, we don't need an architect. We're a self-organizing team, right? We're all a happy band working together. We share architecture responsibility. I've rarely ever seen that really work. I think there are usually one of 3 circumstances. Somebody is given the explicit responsibility of being the architecture owner. They have authority for technical design, and they have responsibility for technical design. When the business wants to know whose fault it is, they want to find someone to come and talk to, right? Second is essentially no one is given that basically official title, but there is somebody on the team who is sufficiently experienced and has a sufficiently large ego that they take the role, right? That may not be the person you wanted to take the role because they may not be very good at some of the aspects of, communication, working with others, leadership, politics. And the third situation, which is even worse in a way, is when the team has a couple of individuals who are effectively at loggerheads over basically the direction technically that we should be taking. And the team either makes compromises that please nobody or doesn't get anywhere. So in most cases, I tend to think it tends to be easier to appoint somebody into the role because it clarifies the situation for everybody and reduces the amount of politics involved. and lets you choose somebody who doesn't just take the role because they have mad coding skills, but because they actually can deal with human beings, for example, which is a key part of architecture. Right? The two don't always go hand in hand, and we know that. Okay. If you are the architect, though, do not act as though this is basically I'm now God, right? You will do what I say. That's not what your role entails. Your role is essentially to empower the team with architecture. So you want to promote architectural thinking. You want to talk to the team about the idea of quality attributes, of constraints, of structure of the system, and being able to reason about what's going to happen, right? And working with the business to understand the trade-offs that they want to make between the various quality attributes that you're dealing with. You want to transfer those skills that you have to your team. These people may want to be architects themselves one day. Help them, right? Don't squash the knowledge all to yourself. The more you can eventually sit back and do nothing, the better. I have a dream, which is basically my smoking jacket in a room and my one of those big globes that basically you can open up and has basically drinks inside. I'm still working towards it. Create opportunities for safe practice. So one of the things that I always say is a bit difficult is, I learned a lot by breaking things. And that's an advantage having been in the industry in the early days. Nowadays, people are more resistant to you breaking things. So you have to create ways that people can learn for themselves, pair with them on stuff, okay? Or the other thing is architectural hoisting. If you create frameworks, for example, that's one of the ways to become brighter. What should use safe messaging between two processes. We take away most of the problems you have understanding messaging. That lets your team get on with the business of sending messages between systems, building things that effectively are new processes that talk across messaging platforms. You have enabled them to put aside that piece of complexity for now and keep designing the bits of the system they can work with at their level of experience. Delegate design authority, right? That's one we do quite a lot. You can be the architect for the next project. I will mentor you and help you do it. Okay? Nothing is better for actually protecting your role than making the other guy do it, because he's usually been moaning about it, and you say to him, great, stop moaning about it, do it, right? And after a while they'll say, I don't want to do it anymore. And design together. So this is the one I always tell my team is that you cannot impose an architecture on a team. Don't come to them with a document and say, here is the architecture. I've been away to the mountain. I've come down with my tablet of stone for the architecture. Please implement it, right? You go to a room together and essentially to get as a team, you figure it out. And in design, there's a really good idea called the architecture design workshop. And the idea is we say, you have a workshop, the whole team is invited. At the beginning, you say, here is the problem, right? So in our case, here are the key risks I want you to solve. Here are the key challenges we're facing with this project. Go away and sit there for 5-10 minutes, scratch out your idea on a piece of paper and some post-it notes. Right? It's important to give people time on their own to have a think. Then what you do is you say, okay, everyone's going to come up and present their idea. And you have to remind them there are no bad ideas. Because I've seen some of the things that people think is my crazy idea, that everyone goes, wow, that's a brilliant solution to the problem we wouldn't have thought of, right? When the person presents their idea, you do not critique it at that stage. Let them present and tell what their idea is. Then you go to the next stage when you critique all the ideas. And generally, you can have a simple process of saying, well, we'll eliminate this, eliminate that. It doesn't meet our quality attributes, etc. Here are our candidates. Let's look at which ones we prefer. Okay? But get the whole team to buy into the process of they are the ones that created the architecture. Never impose architecture. It will not work. Sometimes like I enter a situation where the team says X, I know it will fail, and we have to do Y. That is my failure, not theirs. Right? I have failed to communicate well enough as to why we were forced to impose that decision. But I always regard that as my failure. Okay? And I'm done. I don't know if we've got time for questions or whether we're... okay, I think we're pretty close to time. Does anyone have any questions? You can find me after the party if you want. I'll happily take questions there instead. I know everyone's not always comfortable with asking questions in this kind of environment. And it may take 10 minutes to think about what you want to say. So feel free to come and ask me afterwards. Otherwise, question, they'll come in there. Lady at the back. Right. Okay. Yeah, I will do. Sure. Yeah. So the question is, you've joined a team. The team were handed an architecture they don't believe in. How do you encourage them to help them own the architecture and move forward? And really, I would start with design workshops. I would say, okay, let's all sit down together and itemize the problems with the existing platform. And I'd treat that as just a session, let it get it off their chest. And then I have a separate session which says, how can we move forward? What steps can we take? And the thing is, you may have to provide a lot of guidance because they may have no idea how to get out of the mess that they're in. But what you do is you lead them through and you say, anyone have any ideas? Take their ideas, present a few options to them, ask them to evaluate the options. Even if you know that one of them is the best, it's quite often you should know there are maybe 2 or 3 different choices, and you can present them and ask them to talk about it. You want to encourage them in the process of feeling that they have ownership of the new direction. You have to say the past is the past. I can do nothing about it. When I came to Huddle, they had a schema that was awful. And they had a very fat monolithic application, and they couldn't really scale their process in terms of the number of teams they had. I had to talk to them about, at the time it was called SOA, it was called SOA, but what's now microservices. Talk to them about moving in that direction to help them facilitate that. They didn't necessarily have the vocabulary, but they kind of understood the problems that they had. You just workshop it with them. Interviews with them as well. If they feel uncomfortable talking collectively, you have shy people in the team, then do one-to-one interviews with them. Try and find out what they think. Okay. Next question. Right. Yeah. Yeah. Okay. I mean, I'd always go for diagrams, right? And you can start with whiteboard diagrams that you photograph on your phone. Yeah, C4 is C4 is a really good place. The other thing is I look for what are the petitions now and where could they be. There's a great technique in DDD called context mapping, and that really what you do is you say what is the current status, and do that to figure out basically what your problems are with your context maps and your bounded context. Those are so I would do diagram-based representation of what it is. You all know the narrative, right? Don't bother to write the narrative down if everyone knows that. And then you can use that to start reasoning about your problems and where you need to go. Anyone else? There's someone over there. Okay, feel free to come and ask me questions. I am on. We'll to go back to the beginning, but I'm iCooper on Twitter. So feel free to just track me down on Twitter. Essentially, if you need to talk to me that way, I'm more than happy to answer questions on Twitter, and you can DM me. And if it's complicated, I'll exchange email addresses, and we can talk about it basically via email. Right? But I'm more than happy to help. Okay, thanks very much.